So yeah, this stuff we're talking about today is always, always, always heavily tested on the SAT and stuff like that. Anybody know what this formula is for? Does this look familiar to anybody? Does anybody have any idea what this formula is for? F equals 9/5 C plus 32. Have you ever seen this formula before? Do you know what anything that would have an F and then a C? Think about it. It was pretty cold outside, wasn't it, today? Ah, there you go. See how I was getting there? So yeah, this is the formula that we would use if you go to Canada and they say, whoa, what just happened there? Come on, how hard is it to highlight that? Come on. All right. If you go to Canada and they say it's 20 degrees outside, that doesn't mean anything to you, does it? Is that cold or hot? Because that's 20 degrees Celsius, right? So what we want to figure out, what does that mean, whoa, in Fahrenheit, right? Well, that's where this formula comes into play. Well, what's the only thing you do here? You plug in a 20. So you go 20 times 9/5 plus 32. What's 20 divided by 5? 4. What's 4 times 9? 4 times, so 20 divided by 5 is 4. 4 times 9 is 36. What's 36 plus 32? 68. So what that means is 20 degrees Celsius is the same thing as 68 degrees Fahrenheit. So if they say it's 20 degrees outside, what does that actually mean to them? Is it cold, kind of warm, nice, comfortable, or really hot? 20 degrees would be nice and comfy, wouldn't it? Like that's what I keep my house at, 68 degrees. Like it's probably 68 degrees. It's probably around 68 degrees right now in the classroom, isn't it? Pretty close. Like it's a nice, comfortable temperature. Maybe a little bit on the chilly side, but not bad, right? Now, that's not what we're doing today, though. The question is, what if I want to go the other way? What if I want to take a number like 30 degrees Fahrenheit and put that back into Celsius? Do I need a different formula? No, the answer is no. I don't need a different formula. But what I would like to do is sometimes it's very useful, to take that formula and just kind of rearrange it. And right now it's solved for Fahrenheit, right? Solved for F. If I want to go the other direction, what would be useful if I had this formula solved for? I want to basically get this formula solved for C. All I'm doing is moving stuff to the other side. Right now it's solved for F. I want to just solve it for C. I want to rearrange this formula. So what would I get rid of first here? That 32. So I'm going to minus 32. And then what would I have on the left side? F minus 32 is F minus 32. That's all that is. On the right side, I have 9/5 C. I don't have C by itself yet. I need to get rid of that 9/5. How can I get rid of that 9/5? Instead of multiplying by 9/5, I want to divide by 9/5, but how do we divide by a fraction? We multiply by its reciprocal, 5/9. So what I want to do is I want to times that by 5/9. Well, That's all that really is I would get, now, on the right side, all I have left is C. That's what I want. On the left side, I have exactly that, 5/9 times F minus 32. This formula, it kind of looks like a new formula, doesn't it? But what is it useful now for? Yeah, before I had this formula. Now I have that new formula that basically said C, I'm just going to move the C to the left side here. What was it? It was 5/9 times the quantity of F minus 32, right? That's what it was. Are these two formulas different formulas? No, they're the exact same formula, aren't they? But we use them for two different things. We use this to go from Celsius to Fahrenheit. Now we can use this formula, which is nothing more than a rearranged version of it, to go from Fahrenheit into Celsius. That basic skill of just being able to take a formula. How many different formulas are there in the world? Millions. Like there's formulas for everything. A squared plus B squared equals C squared. We have a quadratic formula. We have physics as nothing but formula after formula after formula. Chemistry, nothing but formula after formula after formula, right? Like that's all the world is, basically all these basic formulas. E equals mc squared, right? Like that's a basic formula that you've heard of in your life. Well, right now, it's solved for energy, right? What if I want to solve it for mass? Can I use this formula and get it to be solved for mass? Sure. How would I move that c squared to the other side? Oh, how is this c is connected to the m with multiplication, so how would I move it over there? You would divide it over there. These two formulas, are they really the same formula? Yes, they really are. Why would we want to take one formula, though, and sometimes solve it for E, sometimes solve it for M? Heck, I could write one that's solved for C. Why would I ever want to be able to do that? Here, I want to solve for the E, the energy, right? Well, maybe the next problem, I have the E and I have the C, I want to solve for the M, right? Another example. Do you guys know what this formula is for? D equals RT. No. Distance equals rate times time. I can use this formula to find the distance if I go 50 miles an hour for 3 hours. How far would I have driven? I would go 150 miles. Right? That's easy. But what if now I'm taking a trip? I know the trip is 500 miles. I want to be there in 4 hours. How fast am I going to have to drive? Well, can I use this same formula? Well, I can, but what am I trying to solve for here? Rate. So I want a formula that says rate equals something. Can I manipulate this formula to make D equals RT? Come on. Can I manipulate this formula, D equals RT, to make it say rate equals something? What would rate equal? How would I get rid of this T? You would divide. This would be the same thing as d over t, right? So now I have this formula that I can use to find the rate. I said what, 500 miles that I have to drive? And how fast do I want to be there? 4 hours. Great. What's 500 divided by 4? How fast am I going to have to drive? 125 miles an hour. Pretty sure it's not going to happen, right? Like, I'm not going to be able to average 125 miles an hour. It's not just getting to 125. It'd be the whole time going that fast, right? Like, that's probably not going to happen. So, but the idea here is I can now take this one formula and I could change it to solve it for r. Could I also take that formula and solve it for t? What would t equal? How would I get rid of this r? Divide. So d divided by r. So now I have this formula. What would be a benefit of having this formula? What kind of problems could I easily solve? When would I want to solve for time? How long is it going to take me to get somewhere? If I drive 200 miles at 80 miles an hour, how long is that going to take me to get there? Well, what's 200 divided by 80? What is it? 2.5. So it's going to take me 2.5 hours. What we're doing basically is this. There are so many different formulas in the world. There really is. There's formulas for all kinds of things. And almost every formula has multiple variables in it, right? Because, like this one, distance equals rate times time. Well, sometimes we have a rate and we have a time and we want to be able to solve for the distance. But sometimes we want to use that same formula in a different way. Sometimes we have the distance and the time and I want to solve for the rate. Sometimes I have the distance and the rate and I want to solve for the time. Like, does that kind of make sense? So all we're doing is taking different formulas and solving for one or a different letter. That's really all this is. So here's a generic